Hi everyone, today I would like to present our project. The project is development of apps software for designing high voltage AC substation grounding system with different shapes of grid with or without rods.
Introduction. Substation is an integral component of the power system to guarantee the distribution of power to customers. AC grounding system grid is an electrical network connected to the earth. Grounding system is necessary for the efficient delivery of electricity and safety.
What are E-touch and E-step?
Touch potential, E-touch, is the contact between the object being energized and the foot of the individual in contact with the floor as shown in Figure 1.
Figure 2 shows that the step potential, E-step, is the tension between the feet of a person standing next to the energized ground surface.
Types of grid.
First, square grid. Second, rectangular grid. And L-shaped grid.
Novelty. Nowadays, there are a lot of calculation software in the market which are mainly calculation tools that can design a safe grounding system such as ETAP, EDSA, SIMGR and SKM as the most popular and most used grounding system software, but no one of them combines the theoretical aspect of grounding with calculation method. The software seems to demand considerable subscription payments which may be burdensome for small or even medium-scale consulting firms. Contribution. Design and develop an apps for education purpose to ensure the calculation for designing the AC substation grounding. User-friendly, and it is also suitable for engineer and designing AC substation as it follows the IEEE 800-2000 standard. The apps is fast and robust. Accurate. Commercialization.
Firstly, cheap apps and easily to download. Secondly, user-friendly. And the AC substation grounding design apps is very important for every consultant as it is easy to use compared to they need to calculate manually. Methodology. The design procedure of designing of AC substation grounding according to IEEE standard. Plan is requiring to identify the goal of developing apps, target users and app features. Figure 3 show the flow chart of the project. There are few samples has been calculated which are square grid with and without ground rods, rectangular grid with and without ground rods, and L-shaped grid with and without ground rods. Table 1 show the parameters and value of manual calculation. This slide will show the steps and interface of application to design grounding system. First step and interface of apps is field data. Second step and interface of apps is conductor size. Third step and interface of apps is grid data. And the final step is result. This is the last result from the apps. We also provide video demonstrations of using this application. You can click the link in the description section below. We chose only one parameter to describe the result of this finding, which is the E-step value. The three tables of grip shape types show that there is a 35% difference between calculations manually and calculations using applications. And the last of this presentation is conclusion. The application software of the AC substation grounding system with different types of grid shapes for the IEEE standard with and without rods is developed. This software will automatically calculate and verify the safety of the design of AC substation grounding of square grid without and with ground rods, rectangular grid with and without ground rods, and L-shaped grid with and without ground rods. In order to make sure the design is safe, the comparable values such as EM and ES must be less than E-touch and E-step value. And the last point of conclusion are from the percentage difference between manual calculation and app calculation is less than 10%, which is acceptable, and this shows that the application is compatible to be used for education purpose. Thank you very much for your attention throughout this presentation.